Good morning all of you. In the last session I had completed the types of bitumen and test on bitumens. Okay, in today's session I will move on to the next topic, that is pavement design. Pavement design. Okay, we all know that the pavement is a structure consisting of superimposed layer of materials above the natural soil subgrade. Is it clear? The pavement is a structure consisting of superimposed layer of materials above the natural soil subgrade. Okay, and the primary function of the pavement is to transfer the stresses coming on it to the soil subgrade. Is it clear? Means to withstand the stresses which is coming on the pavement and also transfer the same to the soil subgrade. It is the primary function of pavement. Okay, for an ideal pavement there are some requirements. Okay, there are about 6 requirements for an ideal pavement. Then what are those requirements of an ideal pavement? Okay, if you go for the requirements of an ideal pavement, requirements of an ideal pavement, okay, the first one it is the pavement should have sufficient thickness, okay, to transfer the stresses safely to the lower layers. Is it clear? The pavement should have sufficient thickness. The first it is sufficient thickness. Okay, second one it is the pavement should be structurally strong. The pavement should be structurally strong enough to resist the all kind of stresses imposed on it. The pavement should be structurally strong enough to resist the all kind of stresses imposed on it. Is it clear? And the third one it is, okay, the pavement, okay, should provide the adequate coefficient of friction to avoid the skidding of vehicles. Is it clear? Means there should be adequate coefficient of friction, okay, to avoid the skidding of vehicle. It is adequate coefficient of friction. Adequate coefficient of friction. Okay, and the next is the pavement surface should be smooth and even as far as possible. Okay, that the pavement then will provide the comfort for the road users who are traveling at the high speed. Means to provide the comfortness for the road users who are traveling at the high speed, okay, for those vehicles you need to provide the smooth and even surface as far as possible. Means the pavement should be smooth and even. Smooth and even as far as possible to provide the comfortness to the vehicles which moving at the high speed. Okay, smooth and even. Smooth and even. Is it clear? And the pavement should provide a least noise from the moving vehicles, or the pavement should produce a least noise from the moving vehicles. Okay, fifth one it is least noise. Produce least noise from the moving vehicles. Is it clear? And the last one it is the pavement surface should be impervious. The pavement surface should be impervious. Impervious surface. Is it clear? Okay, these are the 6 requirements for an ideal pavement. Is it clear? Means the first one it is the pavement should have sufficient thickness to distribute the load to the lower layers. Okay, and the pavement should be structurally strong enough to resist the all kind of stresses which is imposed on it. Then third one it is the pavement should have adequate coefficient of friction to avoid the skidding of vehicles. Next fourth one it is the pavement surface should be smooth and even to provide the comfort for the vehicles which is moving at the high speed. Next it is the pavement surface should produce least noise from the moving vehicles. Next it is the pavement surface should be impervious, okay, to prevent the entry of water into the pavement layers. Is it clear? Okay, this is regarding the ideal requirements of, or we can say requirements of an ideal pavement. Is it clear? Okay, the next is types of pavement. Types of pavement. Okay, basically based on the structural performance of the pavements, we are going to classify the pavement into two types. Okay, one it is flexible pavement. Okay, another one it is rigid pavement. Okay, the one that is flexible pavement, another is a rigid pavement. Flexible pavement is your bituminous pavement, that is a black topped surface, and whereas the rigid pavement is your cement concrete pavements. Is it clear? Okay, then what is the difference between your flexible pavement and rigid pavement? Okay, there is lot of differences between your flexible pavement and rigid pavement. Okay, here you are going to deal with some of the major differences. Is it clear? This is very important, the differentiate between your flexible pavement and rigid pavement. Okay, if you consider the some of the features, okay, using some of the features you are going to differentiate your flexible pavement and rigid pavement. Okay. Features. Okay, number one it is flexural strength. Flexural strength. For a flexible pavement, the flexural strength is low or negligible. Low or negligible. Okay, and for a rigid pavement, the flexural strength is more. We can say high flexural strength. Is it clear? And the second one it is design principle. Design principle. Okay, the flexible pavement will be designed, okay, by a layered system concept. Okay, layered concept system. Layered concept system. Whereas the rigid pavement will be designed, okay, as a plate theory, by slab action. Plate theory. Okay, slab action. Okay, in the rigid pavement they are going to design by assuming a pavement as a flexible plate. Okay, next it is stress. Okay, the types of stresses which is acting on the flexible pavements are compressive stresses. Compressive stresses. Whereas in rigid pavement, the stresses acting on the pavements are tensile stresses and temperature stresses. Tensile stresses and temperature stresses. Temperature stress. Okay, next, transfer of stress. Okay, transfer of stress. Okay, in the flexible pavements, the transfer of stress will be from grain to grain, means there will be a grain to grain stress transfer, one particle to another particles. Okay, whereas in rigid pavement there is no such transfer. Is it clear? In the flexible pavement it is grain to grain transfer, whereas in rigid pavement there is no such transfer. No such transfer. Okay, the next is deformation. Deformation features. Okay, the deformation of the layers above will be reflected on the layers below. Is it clear? Means for the flexible pavement, if the deformation occurs in the above layers, the same will be reflected in the below layers. Okay, whereas in the rigid pavement, if it is any deformation, okay, then the deformation does not reflect in the lower layers. Is it clear? Deformation reflects in the layers below. Okay, whereas in rigid pavement, deformation, if any, okay, not reflected in layers below. Not reflected in layers below. Is it clear? This is regarding the deformation. Is it clear? Okay, we have some more features. Next it is material. Next it is material. Okay, for a flexible pavement, it is a granular materials. Granular materials. Whereas for rigid pavement, the material is Portland cement concrete. Portland cement concrete. Okay, the materials for your flexible pavement is a granular materials, whereas for rigid pavement is a Portland cement concrete. Is it clear? And number of layers. Number of layers. Okay, in the flexible pavement, above the subgrade there will be a 3 to 4 layers. Okay, whereas in rigid pavement, above the subgrade there will be only 2 layers. Is it clear? Means 2 to 3 to 4 layers. 3 to 4 layers above the soil subgrade. Whereas in rigid pavement, 2 layers above the soil subgrade. Is it clear? Next, if you go for function, the function of the flexible pavement is to provide the support capability. Provide the support capability. Whereas in the rigid pavement, the function is to prevent the pumping. Okay, that is ejection of soil slurry through the joints and cracks. Is it clear? The function of the flexible pavement is to provide load support capability, whereas the rigid pavement function is to prevent pumping. To prevent pumping. Is it clear? And one of the major differences, binding material. Binding material or binder. In the flexible pavement, they are going to use bitumen as a binder, whereas in the rigid pavement, they are going to use cement as a binder. Cement as a binder. Is it clear? Okay. These are the some of the major features and the difference of the flexible pavement and rigid pavement. Is it clear? Okay. This is regarding the flexible pavement and rigid pavement. Okay. Next, I'll move on to the typical cross sections of flexible pavement and rigid pavement. Okay. Okay. This is soil subgrade. Okay. And this layer is subbase course. This is base course. Then it is binder course, and it is surface course. Surface course. Okay, and it is prime coat. It is tack coat. Tack coat, then it is seal coat. Okay, it is a typical cross section of flexible pavement. Typical cross section of flexible pavement. Next, is a soil subgrade. Next, it is subbase or base course. Subbase or base course, and it is a cement concrete slab. CC slab. Okay, it is a typical cross section of rigid pavement. Rigid pavement. Okay, this is a typical cross section of flexible pavement and it is a typical cross section of rigid pavement. Okay, they may ask you people to draw the typical cross section of flexible pavement and explain the functions of component parts. They may ask draw the typical cross section of rigid pavement and explain the functions of component parts. Is it clear? It's very simple. Okay. First, if you consider the typical cross section of flexible pavement, here you may observe above the natural soil subgrade, you may have 4 layers. The first layer above the natural soil subgrade is subbase course. Usually, we are going to call as GSB, granular subbase. Okay. Above the subbase course, there is a base course. Okay. Usually, there are 2 types of base courses we are going to use in the pavement construction. One, it is water-bound macadam, WBM. Another one is wet mix macadam, that is WMM. Okay, above the base course, there is a binder course. The binder course is also a bituminous mix layer only. Okay, and then usually we are going to provide the bituminous mix like BM, that is bituminous macadam, STBM, semi-dense bituminous macadam, DBM, dense bituminous macadam as a binder course layers. Okay, above the binder course, they are going to provide the topmost layer. That layer is direct contact with the wheel loads, that is surface course. Okay, usually in the surface course, they are going to provide the bituminous concrete, BC. Okay, usually these 4 layers above the natural soil subgrade will be provided for the high type of pavements, that too for high volume roads. Okay, for the low volume roads, they are not providing the 2 layers of the bituminous mix. There is no binder course and surface course. There is only a surface course above the base course. Then, in terms of low volume roads or for low important roads, they are going to provide the 3 layers above the natural soil subgrade. But for the high volume roads and for the high type of pavements, they are going to provide 4 layers, okay, above the natural soil subgrade. Okay, and you may also observe above the base course, okay, there is a thin application of bitumen called prime coat, and above the binder course there is a thin application of bitumen called tack coat, and above the surface course there is a thin application of bitumen called seal coat. Is it clear? We can go for one by one as a function. Okay, first if you consider the flexible pavement, the first it is seal coat. The first will come a seal coat. You may observe the seal coat is a thin application of bitumen above the surface course. Okay, the main function of the seal coat, or we can say the main objective of providing the seal coat on the surface course, it is to seal the voids in the surface course. Okay, to provide the pavement surface impervious. Is it clear? To make the pavement surface impervious, they are going to provide the seal coat, or they are going to apply the seal coat over the surface course to seal the voids in the surface course. To seal the voids in the surface course. Okay, that is a function of seal coat. Okay, the next it is tack coat. The next it is, second one it is a tack coat. Second one is a tack coat. Tack coat is a thin application of bitumen. Tack coat is a thin application of bitumen that is applied above the binder course before placing the surface course. Above the base binder course before applying the surface course. Okay, the major objective or the function of the tack coat is to provide the adequate bond between the 2 same kind of materials. Means 2 bituminous layers. One is binder course, another is a surface course. Okay, the major function of applying the tack coat above the binder course, it is to get the adequate bond between binder course and surface course. Okay, and the next it is prime coat. Next it is prime coat. Okay, the major function of the prime coat is to provide the adequate bond between 2 different materials, 2 different layers of materials. Okay, the one it is base course, another one is the binder course. We know that the base course is a mixture of a dry aggregate mix, that is the stone aggregates and the dust powder, whereas your binder course it is a bituminous mixed layer. Okay, they are going to apply the thin application of bitumen above the base course before placing the binder course. Before placing the binder course to provide the adequate bond between base course and binder course. Base course and binder course. Okay, that is regarding the prime coat. Okay, next comes to your layers. The first layer it is surface course. First layer is surface course. Okay, and what are the requirements for ideal alignment? We have discussed, no? Okay, majority of the requirements will be come to your surface course function only, because the layer which is in direct contact with the wheel load, that is a surface course. Okay, your surface course should be sufficiently thick to distribute the load to the lower layers, that is the first function, and your surface layer should be structurally strong to withstand the all kind of stresses imposed on it, and your surface course should be impervious to prevent the entry of water into the pavement layers. Then your surface course should provide adequate coefficient of friction to avoid the skidding of vehicles. Is it clear? Then your surface course should be smooth and even as far as possible to provide the comfort for the vehicles which is moving at the high speed. Okay, and your surface course should provide least noise from the moving vehicles. Is it clear? These are the functions of surface course. Okay, the surface course should be smooth and even. Then surface course should be impervious. The surface course should provide adequate coefficient of friction. Then the surface course should be structurally strong, should produce least noise from the moving vehicles. These are the functions of surface course. Is it clear? Okay. Next, below the surface course, it is binder course. Okay, the binder course is also a bituminous mixed layer, but compared to your surface course bituminous mix, in the binder course bituminous mix, there is a slightly less bituminous content, and the aggregates is not such superior quality in the binder course, means there will be a less superior than surface course. Is it clear? Means for the binder course, the bitumen content is less compared to surface course, and also the aggregates used in the binder course are less superior than surface course. Okay, the major objective of providing binder course is to transfer the stresses from surface course to the base course. Okay, whatever the load which is coming from the surface course to the binder course, no, and those stresses will be transferred safely to the base course. Okay, that is the main function of the binder course, to transfer the stresses coming from the surface course to the base course, and also it will minimize the cost of construction, because we know that if the surface, the binder course is absent, then you need to provide this much of thickness of surface course itself, that is superior quality materials and high bituminous content. Then the cost of construction will be more, no? Okay, by providing the binder course bituminous layer, we can also save the cost of construction. But the major function of the binder course is to distribute the stresses, okay, coming from the surface course to the base course. Okay, next it is base course. Next it is base course. The major function of the base course is to provide the subsurface drainage. Okay, in the flexible pavement, the major function of the base course is to provide the subsurface drainage, and also, okay, which will distribute the stresses coming from the binder cores to the subbase cores. The base cores will distribute the stresses coming from the binder cores to the subbase cores. Is it clear? But the major function is to provide the subsurface drainage. Okay, that is regarding the base cores. Next it is subbase cores. Subbase cores. Okay, it is the layer which is in direct contact with the soil subgrade, the natural soil subgrade. Okay, and the major function of the soil, the subbase, that is GSB, granular subbase layer, or you can say subbase cores, it is to distribute the stresses coming from the base cores to the lower layer, that is natural soil subgrade. Distribute the stresses coming from base cores to the soil subgrade. Is it clear? Okay, and the last layer, it is subgrade, that is soil subgrade. Is it clear? Okay, whatever the stresses which is coming from all the layers above the soil subgrade, those stresses will be withstand. Means the stresses which is coming from the above layers, your subgrade has to receive the stresses coming from the above layers. Is it clear? Means the major function of the subgrade is to receive the all kinds of stresses and all the stresses which is coming from the above layers. Next, if you move on to the typical cross section of rigid pavement, okay, we know that for the rigid pavement we have only two layers above the natural soil subgrade. Okay, one it is subbase or base cores. Either they may provide the base cores GSP or subbase core. Either they may provide the subbase cores GSP, granular subbase, and the base cores like WBM and WMM above the natural subgrade. Any one layer, GSP or base cores. And above the GSB or base cores, they are going to provide the cement concrete slab, CC slab. Means above the natural soil subgrade, there will be only two layers. Is it clear? Okay, and this is a typical cross section of a flexible pavement. If you move on to the functions of your rigid pavement component part, first one it is CC slab, that is cement concrete slab. Usually in the rigid pavement they may use the PCC, plain cement concrete, or they may use the RCC, that is reinforced cement concrete, or they may use the PSC, pre-stressed concretes. But the rigid pavement will be designed, that is CC slab will be designed for a flexural stress of 40 kg per centimeter square. Means the flexural stress, okay, should be at least 40 kg per centimeter square, not less than 40 kg per centimeter square. At least the flexural strength of concrete, it may be a PCC or RCC, PSC, anything. Okay, the flexural strength of concrete, the flexural stress of concrete should be at least 40 kg per centimeter square. Is it clear? And what is the function of CC slab? Is it clear? Okay, as there in your flexible pavement, the same functions will be applicable for CC slab. Okay, the CC slab have sufficient coefficient of friction, adequate coefficient of friction to avoid the skidding of vehicles, and the pavement surface should be smooth and even. Is it clear? And should produce the least noise from the moving vehicles, and it should be impervious to prevent the entry of water. Is it clear? Means whatever the functions of the surface cores in the flexible pavement, the same may be applicable for your cement concrete slab in the rigid pavement. Is it clear? Okay, the next it is subbase or base course. Subbase or base course in the rigid pavement. Is it clear? There are about 4 functions of subbase or base course providing above the soil subgrade and below the CC slab. Okay, I have told earlier itself they may use the subbase course or base course above the soil subgrade, any one layer. Either they can use a base course or subbase course. Okay, the first function of providing subbase or base course above the soil subgrade is, okay, to provide the support capability for the CC slab. To provide support capability. To provide support capability. Support capability for the CC slab. Okay, and second one it is to reduce the thickness of CC slab. To reduce the thickness of CC slab, and thereby we can save the cost of construction also. There will be less cost of construction. To reduce the CC slab thickness, they are going to provide the subbase course or base course above the natural soil subgrade. Okay, and number 3 it is, okay, to prevent the mud pumping. To prevent the mud pumping. Okay, to prevent the mud pumping. What do you mean by mud pumping? Ejection of soil slurry through the joints and cracks of the pavement. Assume that if there is no subbase or base course above the soil subgrade, then whatever the soil subgrade will be there, no, from that soil subgrade, the soil slurry will be ejection through the joints of and cracks of CC slab if the subbase course and base course are absent. If the subbase and base course are absent, then soil slurry from the soil subgrade will be ejected through the joints and cracks of the rigid pavement. Okay, by providing the base course and or subbase course, we can avoid the ejection of soil slurry through the joints and cracks of CC pavement. Is it clear? And one more it is, number 4 it is to increase the service life of the CC pavement. To increase the service life of the CC pavement. To increase the service life of the CC pavement, they are going to provide the subbase or base course above the soil subgrade. Okay, and the bottommost layer of the rigid pavement is a soil subgrade. The same function as your flexible pavement for the soil subgrade. Means the soil subgrade is prepared to receive all the stresses which is coming from the above layers. Okay, that's why the soil subgrade is compacted for the desired density at OMC, optimum moisture content. Is it clear? The soil subgrade is designed, or we can say the soil subgrade is prepared to receive all the stresses from the above layers. Is it clear? Okay, this is regarding the typical cross section of rigid pavement and flexible pavements and their component parts and functions of component parts. Functions of component parts. Okay, this is very important in point of your examination. Okay.